Hi everyone! In this video I'm going to show you how to create a well-formatted figure using MATLAB. So here's a new MATLAB window. So you could click on New Script or New Live Script. I'm going to use the Live Script because that's going to show our figure on the right side at all times. Okay, so let's create a new data set. It's going to be a time series describing the speed at which I'm able to ride my bike. So that's going to have a time vector from 1 to 100 seconds and our speed vector. That's going to be based on a constant acceleration of 0.231 meters per second square. Okay, so let's go ahead and plot this. When you're ready, you just hit run. That generated our vectors, time, and speed, and it created our plot. And you can see that the workspace also got populated with our two new vectors. So let's say that I also performed some actual measurements on my bike. So let's create a new time vector. My time vector is going to go from 10 to 40 seconds at every 10 seconds. And these are the readings that I performed in my bike speedometer. Let's see that we got 3, 5, 6, and 10 meters per second as my measurements. And let's do a little bit of cleanup. Great, so you have your first plot. Now how do you add your second data set to that plot? We are going to use the hold on function and plot our second data set, t measured versus speed measured. And don't forget to add hold off at the end. Here you see our theoretical data set in blue and our new experimental data set shown in red. So there are several issues, formatting issues with this plot. There's a lot of empty space, the font's really small, and it's missing some elements that we're going to add now. So first, let's take this blue data set and make the line width a little bit thicker. So you do that with the line width code. Let's change it to 1.5. And it's looking better already. The other thing we can do is change the color. And that's not going to work. Nope. We need to actually put that in order. The color has to show up in front of the other bits of code. There you go. Black thick line showing up. Let's make it red. You could also make it dashed, black dashed, let's say, by using dash dash. There you go. Looking pretty good. There's no reason for us to use it dashed, so let's just keep it as a solid line. Now we only have 4 measurements that we're plotting here, so there's no reason to connect them with a line. Let's change that to a point symbol. And you do that by adding O within quotes. That's going to change it to circles, and by default they're empty circles. So let's go ahead and change the marker face color to make them filled. Let's use the letter B for blue. Now they're filled with blue, but the red is still showing on the outside, the red lines. So let's change the marker edge color to also be blue. Great, looking really good. Now let's say we want to make these points a little bit bigger. We're going to change that by entering marker size. Let's choose 8 pixels. Remember, all of the measurements by default in MATLAB are in pixels, the line width, the marker size, also the figure size that we're going to choose later. So our plot's looking pretty good. Still missing a few elements. So let's add an empty line and create a chunk of code here that's going to be all about formatting so that later you can copy and paste it to other plots to keep them consistent. So first, let's go ahead and add a legend. We have 2 data sets, so we need 2 legend entries, and they're going to show up in order. Then we go ahead and hit run. By default, the legend will show up on the top right, but we don't really want it there because that's where our data is showing up. Let's put it on the left instead, where there's a lot of empty space. You can change that by entering a location, and we're going to choose Northwest. Now let's change that font size to be a little bit bigger. Let's choose a font size of 14 points. Run. Looking much bigger, much better. Now let's go ahead and add some axis labels. So our x-axis and a y-axis. Our x label is going to be time in seconds. Don't forget the units. And our y label is going to be bike speed in meters per second. And now we're going to use set GCA to change the font size and the line width of both axes at the same time. Let's scoot things around a little bit so you can see the whole code. So let's change the font size to 14 to stay consistent with our legend. Now let's do the same thing with line width. Let's choose 1.5 to stay consistent and run.
Here.
Looking good. Now, as you can see, there's a lot of empty space in this plot, right? And the part that we want to really highlight to the reader is this comparison between the experimental measurement and the theoretical model. So let's change our axis limits. We'll go xlim from 0 to, say, 50. We'll create a little vector and hit run. Let's do the same thing with the y-axis with ylim from 0 to 15. Now that we set our limit, our data set is best showcasing the message that we're trying to put forth to our reader. Now there's one last element that I want to change in this plot, and that's going to be the size and the aspect ratio. We're going to do that by using the code setGCF position. So it says position, but it's really about the size and the aspect ratio of our figure. Now, as you can see here, this plot has an almost square aspect ratio. That means that when you take this and you paste it into Word or LaTeX for your report, it's going to have a lot of empty space on the sides of the plot. So what we're going to do is try to squeeze it a little bit because it's not necessary for it to be so tall. So for the first two numbers, we're going to use 10 and 10. That's the padding in the X and the Y direction for the beginning of the margin of the figure. And then the next two numbers are going to be the width and the height of our figure in pixels. So we're going to use 600 by 300. And you could use some code to change the default units from pixels to whatever you want, but I don't mind staying in pixels. After you hit run, you'll see that the figure got squeezed in the Y direction, and that's going to look much nicer in a report, especially based on the shape of our data set here. So now let's go ahead and right-click on the figure and hit Copy Output to copy it into our report. You could also open the figure in a new window and export it that way, or there's another little button that shows export, and you can save that as a PNG file or as a JPEG. And there's our exported PNG figure. Now let's say that I have a report that I'm working on in Word, and you're going to import your figure there and add a caption. So let's say I choose my font to be ×12. The key thing here to keep in mind is that the font size of my figure is a little bit smaller than my report font size, but not much smaller. So a reader would not have any trouble reading my figure because the font size is not that different. And going back to MATLAB, you're going to see that I've organized my code in 3 sections. The first section has my input data. The second section has my actual plot. And the third section has all of the graphical elements. So I could take that chunk of code in my third section there and copy it into any other figure that I'm creating to keep my formatting consistent so that all the figures in my report have the same aspect ratio, the same line widths, etc. So yeah, this is an example of a simple, well-formatted figure in MATLAB. There are many ways to do this. There are many ways to format figures using MATLAB, but this is probably the best way to get started.